Okay, so today's date is the 25th, and your objective today is to use, translate, and make connections among algebraic, tabular, graphical, or verbal descriptions of linear functions. So we're going to be connecting algebraic, which means equations, tabular, which means tables, graphical, which means graphs, and verbal descriptions, which means word problems, to linear functions. Okay. So what we have here is a box that has in the center the verbal, which means word problems. Then you're going to have an equation, a table, a graph, and a question to answer based off of these things. So each time you're given one of those four. You're either given the equation, the table, the graph, or the verbal. You're always given the question that I want you to answer. So this time we're given the equation, and we have to fill in the other things. We have to fill in the table, we have to fill in the verbal, we have to fill in the graph. So you have to have the verbal part first to know what your headings are for the table and to know what your axes are for the graph. So our equation is y equals 35 plus 15x. So we have to come up with a word problem that would have 35 plus 15x. So this is your chance to be creative with word problems. Okay, so my story is going to be about a yoga class at the gym. So yoga class at the gym. Okay, and so what does that 35 mean? That 35 is a flat rate. So that means, or a flat amount. So I'm going to say the yoga class started with 35 people. So yoga class at the gym started with 35 people. Okay, so the yoga class started with 35 people. That's the 35. Now that plus 15x means that we're adding 15 people per something. So do you want to think about it as per week, per day, per hour, per month, per whatever you want it to be? So I'm going to say that the class added 15 people. Okay, what's realistic? 15 people per hour is not realistic if you're in a yoga class. Per week or per day, maybe. Per week, maybe. I'm going to go per month. So the class added 15 people per month. So there's my word problem. A yoga class at the gym started with 35 people. The class added 15 people per month. Does that fit this equation? Yeah, 35 people, 15 people per month. So in this equation that I have here, let's go back here for a second and connect our verbal to our equation. What does this x stand for? Remember it said the class added 15 people per month, so x has to be the number of what? It has to be the number of months. So 35 people plus 15 people per month, this y has to be the total people. Okay. Now, the reason why that comes in handy for us to do it there is so that when we do our table and our graph, it's easier. Now, remember, your table is x and y, so I'm going to put x and y there. X was number of months in this problem. Y was total people. Okay. So at 1 month, there were the 35 people that started there, so after a month, it's 35 plus 15 times 1, so 35 plus 15 times 1. You'll notice I just plugged the 1 into that equation, and if you use your calculator, that comes out to be 50 people. After 2 months, it's 35 plus 15 times 2. Plug that in your calculator, and you get 65 people. At 3 months, 35 plus 15 times 3, that comes out to be 80 people. After 4 months, 35 plus 15 times 4 comes out to be 95 people. Okay. Now we're going to use that table of values to do a graph. So on our graph, this x-axis is going to be the number of months. So we're going to say that's 1 month, 2 months, 3 months, 4 months, 5 months, and so on. Okay? The y-axis has to be the total people. And so this is a little bit harder because we've got to get all the way up to at least 95 people. So instead of counting by ones or even by fives, I'm going to count by 10. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. You're going to have to do problems like this where you're going to have to decide that scale. So you just have to use the numbers in your table to figure that out. Okay, so we know that the yoga class started out with 35 people. So 35 is where? 35 would be between 30 and 40. Okay, at 1 month in our table it says 50, so 1 month 50. 2 months is 65. 65 is right between 60 and 70. 3 months was 80. 4 months was 95. And there's your graph. If we were to connect that, would it connect with a straight line? Yeah. Should we connect it? Are months discrete or continuous? Months is a value of time, and time is continuous, so let's go ahead and connect it. Did that make a linear function? Did it make a straight line? Yes. Okay. So our question here is find the value of the function for an input of 7. What's another term for input? X. So go back to your equation where the x is, we're going to put a 7. So y equals 35 plus 15 times 7. So your calculator will help you solve that. 35 plus 15 times 7 comes out to be 140. Now, those numbers really mean nothing in this problem until you put some value to them. What do those numbers mean? If the input is 7, that means 7 months. What does the y equal? Y was the people, so at 7 months, there are 140 people. Okay. So the 7, the input's the x, that's the months. The y, the 140, that's the people. So at 7 months, there are 140 people. So on this problem, you had started with the equation, and you had to come up with a story about it. Be creative, but be appropriate. Okay. Then you had to make a table, and then you made the graph. Make sure when you make the table that you pick numbers that are appropriate. Don't pick crazy numbers. Start with small numbers like 0, 1, 2, 3, 4. That's what I would do every time if I were you. Make sure you fill in your headings. Remember, we put in X and Y, but we also put number of months and total people, so make sure you put both of those. And then we graphed it. Make sure you use an appropriate scale. Okay, so we had to count by 10 so that we could fit it all on there. Remember that we had like 65, and 65 is just between 60 and 70, so make sure you're careful there. And then over here is a question for you to answer. So you're going to be doing, on your own for homework tonight, 4 of these rectangles. And in each one, you're given something different. Okay, so make sure you pay attention to what you're given and fill in the others. So we're going to do one more together. We're going to do this one that's underneath. This time, I gave you the graph. So I gave you a graph this time. So before I can start doing anything, I have to decide what's happening in my graph. So when I look at this, it looks like my graph is starting at 50. Okay, so I'm just going to take some notes about this. It's starting at 50. And then is my graph going up or going down? It's going down, and it looks like it's going down about 5 for every 1. So decreasing 5 for every 1. And that doesn't make a whole lot of sense until I put some units there. What do we want this 1 to be, and what do we want this to be? So what could be something that's decreasing 5 for every 1? Something that could start out at 50. So you have to be creative with this verbal part. So I'm going to talk about, let's see, what do I want to talk about? I'm going to talk about a water cooler. Okay? So I'm going to talk about a water cooler. If I'm going to talk about a water cooler, the 5 through 50 has to be the water. And we're going to talk about that being in gallons. And then this 1 through 10 has to be, we're going to talk about the water cooler and water. It's going to have to be over time. So let's say every hour. So that's going to be hours. Okay, so if we look back over here at my notes, we wrote that it's starting at 50 and it's decreasing 5 gallons for every hour. Okay, and there's the basis of our verbal part of our word problem. We just have to make it prettier, or make it sound prettier. So we're going to say a water cooler holds 50 gallons of water. Now, when you're writing these word problems, this verbal section, everybody should be different. It'll be very obvious if you copy off somebody else's word problem, because everybody should be a little bit different. Everybody should be completely different because you're being creative with your own word problem. So in your notes, we're all writing about the water cooler, but when you're doing your own, everybody should be writing about something different. So water cooler holds 50 gallons of water. Okay. If it's decreasing, what's happening to the water? If it's decreasing, it means the water has to be being used. So we're going to say the water is used at a rate of 5 gallons every hour. Okay. So now that I have that, now I can do my equation. So notice I always go to my verbal. Whatever I'm given, I always do the verbal first, and then I fill in the others. So if I go to my equation, it's going to be y equals. Okay, so it told me that the water cooler holds 50 gallons of water, and it's being used. So that means minus 5 gallons every hour would have to be 5x. Okay, so just like before, I'm going to label the x and y. X has to be hours. Y has to be the water in gallons. Okay. And now we're going to go to our table. It's going to be x and y. Remember, x again is hours. Y is the water. And is that y the water that's in there, or the water that's left in there, or is it the water that's being used? If you think about that, that's the water that's left in there. Okay? So after 1 hour, after 2 hours, after 3 hours, after 4 hours. So after 1 hour, it had 50. We used 5 times 1, so that would have to be 45. And is that true? Yeah, look back at ours. At 1 hour, look back at your graph. At 1 hour, it was at 45, so that's right. That's a way to double check if your graph and your equation is right compared to your graph. So 2 is 50 minus 5 times 2 has to be 40. For 3, 50 minus 5 times 3 has to be 35. 4, 50 minus 5 times 4 has to be 30. And again, if we look back at our graph, is that right? Yeah, if you look back at your graph, 4 is at 30. So we know we have the right equation to match our graph. Okay. So now our question, find the slope of the line. So remember, slope is rise over run. So we pick 2 points, any 2 points you want to pick. I'm going to pick these 2. I just picked them just because I could. You could pick any 2 you wanted. So rise over run, how far down do I go? Now, when I look at that, that looks like I just go down 1, but it's not really 1. I'm really going down 5. Why am I going down 5? Because that's my scale. So I'm not really going down 1, I'm really going down 5 because I'm counting by 5s over here. What's my run? 1. Okay, so there's my slope. My m equals negative 5 over 1. And so what does that slope mean in this problem? The negative 5 is the water, so using 5 gallons of water,